8-1, proving triangles congruent. You're going to be dealing with SSS and SAS today. All right? So first thing you need to do after you get your learning goal down, you can just write it either on your own page or you can just flip the sheet over where you're doing your constructions today and write it on the back of that sheet. Okay? So this sheet that you picked up on the way in, where we're going to complete these, if you just want to turn it over and put it on the back there, that would be fine. Okay, after you complete the constructions, I want you to find a book and open your book to page 406. So the first thing you need to do on these constructions, the first one, construct a triangle starting at point A using all three side links, X, Y, and Z. And then after that, you need to construct a triangle with these two lines, R and W, and that angle. Okay? Very good. We're going to put a time limit on there of about 10 minutes or so. Ready to go? A good question on the second construction was, do you have to only use this angle once? And yes, you only have to use it once. So use that angle once with R and W as lengths of two of the legs. There's the squeaky compass again.
Because it's easy. Oh my god.
Yeah, on this second construction, your third length can be anything. It doesn't have to be R or W. So two of the lengths, one is R, one is W. The third length could be anything you want. Well, let's go ahead and take a look first at the first construction. So here's a picture of my construction that I gave myself a star on. There we go. Now you have something that kind of looks like that. Looks exactly like that? Yeah. Dude. So we were given three sides and we had to start at this point and we're able to make a triangle. Nice. Everyone have a triangle look like that? Okay. Well, how about your next triangle?
Hey, that one looks like mine.
That one looks like yours?
Yeah.
Okay, so we're constructing on this one, we're constructing a triangle given an angle and two sides. So how many of you used your angle and had one side going off here and one side going off this way? Did anyone do their triangle more like that? Where you had your angle and then you had your sides coming off the angle. Okay, note the differences, right? Note the differences between the two. So in one of these, you have, can I get both of those up there? All right. In one of these, you have your angle, and then WR coming off the side of that angle. Now pay attention, we're trying to bring this together now. Here we have an angle. Okay, let's practice listening. Listening means listening with our eyes. That means you're up here. You're actively attentive. Okay, angle, and we have a side, and we have a side. So we have a side, an angle, and a side. Everyone get that in that order. Here we have the given angle, and we have a side, and we have a side. So we have a, what's this? Angle. Okay, so in math, we call this one right here, we call this one side, angle, side. Oh, sorry. Man, that was anticlimactic. Side, angle, side. SAS, right? Okay, go ahead and figure out what we call this one. We start with our angle. And we have we frown on that.
So it's SSS.
Inappropriate, dude. Okay? Hey, you cannot have angle, side, side. Not okay. You can have side, angle, side. That's okay. Okay? Side, angle, side. Notice there are two ways to construct this. Now, I'm trying to make it kind of interesting so that you'll remember it. Okay? But the reality is you could have constructed this two different ways. One way is appropriate, one way is inappropriate. One way works, one way does not work. This right here, notice if I went angle, side, side, this side could have went here, or technically it could have went this way. Everyone see that? We could have closed this angle or this side and made it come in like this. Everyone get that? So really, going angle side side doesn't make the same type of triangle. Okay? Whereas this one, if I have an angle and a side, or a side and an angle and a side, there's no way for me to shift anything here. I'm going to end up with 2 points, there, and that third side automatically has to go through those 2 points. Okay, so two of the things we're studying today, one is called side angle side, which we have on that second construction. The other one is called, what is this one? This is side, side, side. Okay? There's no other way. Was anyone able to construct a completely different triangle using side, side, side? No possible way. Everyone made the same triangle. Did everyone use side angle side here?
Yes.
Did anyone use the other way?
No.
Yeah.
Okay. So if you use the other way, now we know. Knowing's half the battle. That's why we do it. Okay? All right. So what I'd like you to do right now, I want you to take a look at your math books. Open it up to page 406. We're going to repostulate 8-1. I want you to write down the title, what it means. Use a picture to explain it. Repostulate 2. Write down the title and what it means. Okay, use a picture. Oh. All right, well, we're done talking about fish up here. Well, here's my stick fish. We've got a shark. Okay, just in case you're wondering. All right. Reading postulate 8-1. Someone tell me what the postulate 8-1 title is. Grace?
Side, 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 postulate.
Side, side, side. What does it mean? Yeah.
Three sides of one triangle are congruent to another three sides of another triangle. The triangles are congruent.
Good. If 3 sides of one triangle are congruent to another 3 sides of another triangle, then the sides are congruent. This is side, side, side postulate. So if I have this triangle, ABC, and say I have this triangle, and just because we're creative, we'll call it, oh, that's really not the best. That's all right. We're going to go with it. Even though they don't look congruent. We're going to call this one XYZ. Okay? We know, because of their side markings, we have triangle ABC is congruent, unbelievable, my goodness, is congruent to triangle XYZ. Okay? Based on side, side, side. What's the other title? Well, let's go with Haley this time. She had that one.
Side angle side.
Side, angle, side. And Maddie, what does it mean?
It means that if two sides and the angle are equal on two triangles, then the triangles are equal.
Very good. So if I have an angle and 2 sides coming off that angle. So for instance, kind of like that. Okay? Now I call this one A, and we'll call that's angle A, that's angle X. We'll call this side, or let's call this B, and we call this C. Okay? So there we've got ABC. We know that this angle is congruent to that angle with X, Y, Z. Okay? So I know an angle, I now have a side, and I have another side. Those sides have an included angle, right? That way we're using the correct vocabulary, side, angle, side. Okay? So we know because of side, angle, side, triangle ABC is congruent to triangle XYZ. Side, included angle, and side. So the angle has to be touching both the congruent sides. All right. We got it? Questions? All right, we actually did the proof for it, or the picture of it today. Okay, write a 2-column proof. This is number 13 off your assignment today. It's off the mixed side. So given AB is congruent to DC, angle BAC is congruent to DCA, prove ABC is congruent to CDA. Now I'm going to give you the sheet here in a minute. So I just want to point out a few things on this when you're looking at it. First, notice they've actually marked what they're saying up here. They don't always do that. So in the given, they're saying this is congruent to that, but they've even marked it in the picture. That won't always happen. So if they don't do that, you need to mark it. Second, they've done that with the angle. BAC, DCA. Okay? You have two ways right now to prove triangles congruent. If you're going to prove this triangle is congruent to that, you have to use one of two things. Tell your neighbor what one of those two things are. Okay, so I heard that one, and I heard that one. Those are the two ways you know so far. Okay? So one of these you have to use. All right. So right now, work with your partner. Just walk through verbally how you're going to do that. So I've given you your sheet, and you'll notice how much actual space they give you on this to write your proofs today. That's the example side and the mix side. Noticing how much space they give you, which I'm being kind of sarcastic there, you really need to have a separate sheet of paper. Okay? Even you that write microscopically, you need a separate sheet of paper. So get a separate sheet of paper. That's the first thing to do. All right, want to get you working, so here we go. 2-column proof has how many columns? 2. I know, crazy, right?
That was funny if I had one.
All right. First column is called what?
Reasons.
Yes, no.
Statements.
Statements. Good.
And then reasons.
And then reasons. Good. Statements and reasons. All right. Okay, first statement. I always make my first statement, and you're going to see this probably a lot different in other proofs, but I always put all my givens first. That way I've said them. A lot of people that write proofs, probably more than the way I do it, more times than not in your textbooks, you're going to see them give the givens as they need them. Okay, I just give them all first, but my first statement is going to be my givens. AB, congruent, DC. DC, when I think of DC, I think of, anyone know? Yes, well done. Man, perfect. Triangle AB or BAC, congruent to triangle, or excuse me, not triangle, angle, DCA. You guys need to hold me accountable because sometimes my angle marking starts looking like a less than symbol. And math teachers make fun of me. I've actually been in math meetings where they've made fun of me. I went home and cried, to be honest. Okay.
Oh, man.
Well, I didn't, but I thought about crying, and it's really the thought that counts. So. All right. So there we go. We have our givens. It was sad. So hold me accountable. I don't want to be made fun of anymore. Just saying. That's an angle mark, not a less than mark. Oh, yes.
Well, aren't they don't they look the same anyways?
No, that looks like an angle mark. That looks like a less than mark.
They're the same to me.
Oh, they're not the same. Look at the vertical, or the horizontal line and the slanted line.
Oh.
Yeah. Don't get made fun of at math meetings, Kira.
I need to
not
work
fun.
on that now.
All right.
I think you're going to go into any math.
So, do I have side angle side?
Yeah.
Do we have side angle side? We do? I see a side and I see an angle. I don't see another side. We haven't said another side's congruent. Do I have side, side, side? Have I said in my statements you have to have said 3 sides congruent or a side, an angle, and a side congruent? I haven't said either of those. I've said a side and an angle. So the next logical piece would try to find another side. Yeah?
AC is on both of them. It's the same side.
AC is congruent to not AC.
CA.
CA. Man. Now some of you are like, well, why do we do that? Well, think of it this way. If I look at angle A and I were to outline this triangle right here, pay attention, otherwise you'll struggle with this the whole chapter. And if you're talking and you are able to listen and talk, the person next to you might not be able to, which is annoying to that person. They're just too nice to tell you. Okay? So, There we got it. See, neat colors, huh? Yeah? All right, so angle A of the blue, is this blue?
Yeah.
Blue triangle is congruent to angle what? Angle C of the pink triangle. Okay. All right. This angle corresponds to that one. Okay, therefore, when I start this line in this triangle at A and go to C, I have to start with the same angle that corresponds to that angle in the other triangle. C, go to A. Everyone get that? It's because this angle corresponds to that angle. So when I say AC of this triangle, that is the same side as CA of the pink triangle. Because this angle corresponds to that one. You've got to have the same starting point, like if you were to lie the triangles on top of each other. All right? Ask your neighbor if they understand what we're talking about there.
Is that a yes? Okay. Just making sure.
I'm right in between.
Okay. Raise your hand if you do not, or if you get it, if you've got it. Okay, if your hand's down, I assume you don't get it right now, which you're the person I'm going to try to go around and try to see here in a minute.
I don't feel like raising it.
Okay, very good. All right, the reason for that, there's a certain property we call the reflexive property. Not reflective, but reflexive. Reflexive property. Get used to using that. The reflexive property says something is congruent to itself. That's essentially what it says. Get used to using it. You'll use it a lot this year. Reflexive property. Okay, I have now said an angle, or excuse me, a side, an angle, and a side are congruent. Okay, if a side, an angle, a side are congruent, I can now state ABC is congruent to CDA. I have to use that. I should have put a triangle marking there. I have to use that because that is what they're asking us to prove. You want to use that statement. That should be your last thing. How come? By SAS. And then we end our proof with our cool endings. There's mine. Yep. The real ending is QED. I use ZDD. You can use whatever you want. You'll write it down on your quiz, so I have something to read besides proofs. Questions? Okay, now I'm going to be walking around. If you did not understand this, pay attention right back here. If you did not get this part, why that's reversed like that, make sure as I walk around you stop me and ask me. I'm going to try to, I saw a few of you, but, okay? Number 14 is the next one. I want you to write a two-column proof for 14, please. All right, who has it? Oh, not done. Okay, well, while you guys are working, I am going to start. There's S, there's R. I start abbreviating. I need a third side or an angle. What do you got, Julian?
GFH is congruent to DFB because of vertical angles.
GFH congruent to EFD. Emily, what's up? Are these bisectors? They are bisectors of each other, yeah. Okay? We don't necessarily need that. We know that this is vertical angles. Okay? We could say other things like these are bisectors, but that's not going to help us prove our triangle's congruent. So as you're doing proofs and working with shapes, and the shapes get more complex, the figures get more complex, you're going to start going, well, I can say this and this and this, but you have to have like a roadmap of where you want to go. Know where you want to go first. Okay, see 3 sets of wires right now. Make sure you do not have wires in your ears. Okay? All right. Make sure you have the road map to where you want to go. It really is like saying, hey, we're going to drive to Dallas. And then you just start driving. We'll eventually get there, like all roads leads to Dallas, right? So we just start driving, man. Okay, and that's not how it works. You got to have a map, otherwise you're going to be driving around forever. That's how a proof could be. You could start going forever in one direction, and then eventually you're like, oh, I just needed to go 1, 2, and I'm done with my proof. The proofs get more difficult. There's going to be more than 2 steps. This we're done with. Our third statement is triangle DFE, not P. So DFE is congruent to triangle HFG by SAS. Give yourself more room and use a pencil, please. Unbelievable on my part. Okay, we use our Z, D, and D. There we go. All right. Now I notice that when I said one direction, some of you really like all of a sudden were like, oh. Okay. Hey, I wasn't talking about the band there. Okay. All right.
Mr. Clark can go like one direction, and it can be like not that one direction.
Not that.
doesn't count.
The other direction.
He used to always go BT.
Wicked steps.
Yeah,
He always would say BT dub. It was so funny.
All right, your assignment today.
He was sad.
Example side all, no mix side.
So bad.
Do not cross out the mix side. Example side all right now.
He was like,
Okay, on example 2, note it says, from the information given, can you prove they're congruent? So there are some on there you cannot prove congruent. If you can, then write the proof. Okay, I used the cool McCoy script print right there off the computer. Okay?